Welcome to Class 8, Mathematics Chapter Power Play. Today we explore a fascinating question. Are there numbers that are both perfect squares and perfect cubes? We all know squares and cubes. But 64 is special. It is both. 8 squared is 64 and 4 cubed is also 64. So here is the real question. Are there other numbers like 64 and can we describe them all with a single rule? We break down questions step by step to help you understand better. Hit like and subscribe to support the channel. Let us start with what we know. A perfect square is any number we can write as something squared, n squared, 1 equals 1 squared, 4 equals 2 squared, 9 equals 3 squared, and so on. The key insight: for a perfect square, the exponent is divisible by 2. A perfect cube is n cubed. 1 equals 1 cubed, 8 equals 2 cubed, 27 equals 3 cubed, and so on. For a perfect cube, the exponent is divisible by 3. Now, what if a number needs to be both? Let us go hunting. Let us list some squares and some cubes and look for numbers that appear in both lists. Here are some perfect squares. And here are some perfect cubes. There is one that is trivial. There is 64, R star. And look, 729. That is 27 squared and 9 cubed. These numbers appear in both lists. And 4096, that is 64 squared and 16 cubed. There are more than just 64. Now here is where it gets really interesting. Let us unwrap 64 by writing everything in base 2. We know 64 equals 8 squared. But 8 is 2 cubed. So 64 equals 2 cubed, all squared. Using our power of a power rule, multiply the exponents. That gives us 2 to the power 3 times 2, which is 2 to the 6th power. Now watch the cube side. 64 equals 4 cubed. But 4 is 2 squared, so 64 equals 2 squared, all cubed. Applying the same rule, 2 to the power 2 times 3. Again 2 to the 6th power. Both paths lead to the same exponent, 6. 64 is 2 to the 6th power. Let us check 729 the same way. 729 is 27 squared and 27 is 3 cubed. So 729 equals 3 cubed, all squared. Applying the power rule, 3 to the power 3 times 2, which is 3 to the 6th power. Now the cube side, 729 is 9 cubed and 9 is 3 squared. So 729 equals 3 squared. So 729 equals 3 squared, all cubed. 3 to the power 2 times 3. Again 3 to the 6th power. Both 64 and 729 have exponent 6. The pattern is unmistakable. Now the big question. Why is the exponent always 6? Think about it. For a number to be a perfect square, its exponent must be divisible by 2. For it to be a perfect cube, its exponent must be divisible by 3. For it to be both, the exponent must be divisible by 2 and by 3. Look at the multiples of 2. 2, 4, 6, 8, 10, 12, 14. And the multiples of 3, 3, 6, 9, 12, 15 and 18. The common multiples are 6, 12, 18, 24. These are all multiples of 6. The smallest number divisible by both 2 and 3 is their least common multiple, which is 6. That is why our exponents are all multiples of 6. So here is our beautiful general rule. Any number of the form n to the power 6 is both a perfect square and a perfect cube. N to the 6th. Why? Because n to the 6 equals n cubed, all squared, that makes it a square. And n to the 6 also equals n squared, all cubed, that makes it a cube. Let us verify. 1 to the 6 is 1, 2 to the 6 is 64, 3 to the 6 is 729, 4 to the 6 is 4096. All numbers we already found. Every n to the 6 is both a square and a cube. To summarize, numbers that are both perfect squares and perfect cubes are exactly the 6th powers. The exponent 6 comes from the least common multiple of 2 and 3, because 6 is divisible by both. Every n to the 6 is a square, because n to the 6 equals n cubed all squared. And it is a cube, because n to the 6 equals n squared all cubed. You have just discovered a deep connection between exponents and divisibility. That is the real power of power play. Square numbers, cube numbers, and now 6 powers. You can spot the hidden structure inside any power, and that is a superpower worth having. Keep learning and keep growing. See you in the next question.